The 14 volts transformer should be connected to a grounded 110 volts receptacle to minimize the risk of electrical shock. It is important to ensure that the wiring and electrical components meet the requirements of the local building code. All electrical wires should be properly insulated and protected from damage or exposure. The circuit should have appropriate circuit breakers or fuses to protect against overloads and short circuits. If multiple devices are plugged into the receptacle outlet, it could overload the circuit and cause a fire hazard. A faulty transformer could present a fire or shock hazard. The chime may be too loud for young children, causing discomfort or hearing damage. Ensure that the chime button is at a height that is easily accessible for children. As the person who installed the electrical system, you could be held liable if someone is injured or property is damaged due to an electrical malfunction. It is important to provide clear instructions for use and have users sign a liability waiver to protect yourself. It is recommended to have a qualified electrician inspect the electrical system before allowing preschoolers to use it. Restrict the use of the light outlet to low wattage bulbs. Set the chime to low volume and ensure that it is not within close proximity to young children. Provide clear instructions on how to use the system safely and supervise children when they are using it. Consider installing additional safety features, such as surge protectors or ground fault circuit interrupters, GFCIs, to enhance safety. Regularly inspect the system for any damage or loose connections and have it serviced by an electrician as needed. When assessing the electrical safety of a setup intended for use by preschoolers, several key areas should be examined to ensure a safe environment. Firstly, the grounding of the 14 volts transformer is crucial. Connecting it to a properly grounded 110 volts receptacle minimizes the risk of electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing a dangerous voltage from being present on the enclosure or accessible parts of the equipment. Secondly, compliance with local building codes is essential. Building codes are in place to ensure the safety of electrical installations, and adherence to these codes reduces the risk of electrical hazards. These codes specify requirements for wiring methods, materials, and installation practices. Thirdly, proper insulation and protection of electrical wires are paramount. Insulation prevents accidental contact with live conductors, reducing the risk of electric shock. Wires should be protected from physical damage, such as abrasion, cuts, or crushing, which can compromise the insulation and create a hazard. Fourthly, circuit protection in the form of circuit breakers or fuses is necessary to protect against overloads and short circuits. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a safe level, preventing overheating and potential fires. The appropriate size of the circuit breaker or fuse should be selected based on the ampacity of the wiring and the load it serves. Several potential problems should be addressed. Firstly, overloading the circuit can occur if multiple devices are plugged into the receptacle outlet. Overloading can cause the wires to overheat, potentially leading to a fire. The total load on the circuit should be calculated to ensure that it does not exceed the rating of the circuit breaker or fuse. Secondly, transformer failure can present a fire or shock hazard. A faulty transformer can overheat, emit smoke, or even catch fire. Regular inspection of the transformer for signs of damage or overheating is important. Thirdly, the chime volume may be too loud for young children, causing discomfort or even hearing damage. The chime volume should be set to a low level and the chime should be positioned away from children's ears. Fourthly, the accessibility of the chime button is important. The chime button should be located at a height that is easily accessible for children so they do not have to reach or climb to activate it. Regarding liability, as the person who installed the electrical system, one could be held liable if someone is injured or property is damaged due to an electrical malfunction. To mitigate this risk, it is important to provide clear instructions for use and have users sign a liability waiver. Clear instructions should cover the safe operation of the electrical system, including warnings about potential hazards. A liability waiver is a legal document that releases the installer from liability for injuries or damages that may occur as a result of using the system. Several recommendations can further enhance the safety of the electrical system. Firstly, a qualified electrician should inspect the electrical system before allowing preschoolers to use it. An electrician can identify any potential hazards and ensure that the system meets all applicable codes and standards. Secondly, restrict the use of the light outlet to low wattage bulbs. Low wattage bulbs reduce the risk of overheating and fire. Thirdly, set the chime to a low volume and ensure that it is not within close proximity to young children. This will prevent discomfort or hearing damage. Fourthly, provide clear instructions on how to use the system safely and supervise children when they are using it. Supervision is essential to ensure that children do not misuse the system or expose themselves to hazards. Fifthly, consider installing additional safety features such as surge protectors or ground fault circuit interrupters, GFCIs, to enhance safety. Surge protectors protect against voltage spikes that can damage electronic equipment. GFCIs protect against electric shock by detecting ground faults and interrupting the circuit. Sixthly, regularly inspect the system for any damage or loose connections and have it serviced by an electrician as needed. Regular inspections can identify potential problems before they become hazards. Servicing by an electrician ensures that the system is properly maintained and that any repairs are performed correctly. When dealing with electrical systems, always prioritize safety and consult with qualified professionals to ensure a safe environment, especially when children are involved. Understanding basic electrical concepts is crucial for ensuring the safety of any electrical installation. Firstly, voltage is the electrical potential difference between 2 points in a circuit and is measured in volts. It is the driving force that pushes electrons through a conductor. Typical household voltage in North America is 120 volts for smaller appliances and lighting, and 240 volts for larger appliances like ovens and dryers. Secondly, current is the flow of electrical charge through a circuit and is measured in amps. The amount of current depends on the voltage and the resistance of the circuit. High current can cause wires to overheat and potentially start a fire. Thirdly, resistance is the opposition to the flow of current in a circuit and is measured in ohms. All materials offer some resistance to current flow, with conductors having low resistance and insulators having high resistance. Fourthly, power is the rate at which electrical energy is transferred and is measured in watts. It is calculated by multiplying voltage by current. Electrical devices are rated by the amount of power they consume. Ohm's law describes the relationship between voltage, current, and resistance in a circuit. The formula is voltage equals current times resistance. This law is fundamental to understanding how electrical circuits work and how to calculate the values of different components in a circuit. Circuit breakers and fuses are essential safety devices designed to protect electrical circuits from overcurrents. A circuit breaker is a reusable device that automatically interrupts the circuit when the current exceeds a predetermined level. It can be reset manually after the fault has been cleared. A fuse is a one-time device that melts and breaks the circuit when the current exceeds a predetermined level. It must be replaced after it has blown. Grounding is a safety measure that provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing a dangerous voltage from being present on the enclosure or accessible parts of the equipment. Grounding is typically achieved by connecting the metal enclosures of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. Ground fault circuit interrupters, GFCIs, are devices that protect against electric shock by detecting ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person who is touching a live wire. GFCIs quickly interrupt the circuit when a ground fault is detected, preventing serious injury or death. Electrical codes are a set of rules and regulations that govern the safe installation and maintenance of electrical systems. These codes are developed by organizations such as the National Fire Protection Association, NFPA, and are adopted by local jurisdictions. Adherence to electrical codes is essential for ensuring the safety of electrical installations. When working with electricity, it is important to follow safe work practices to prevent electric shock and other injuries. Firstly, always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Secondly, use insulated tools and equipment. Insulated tools protect against electric shock. Thirdly, never work on electrical equipment in wet or damp conditions. Water is a good conductor of electricity and can increase the risk of electric shock. Fourthly, be aware of your surroundings. Avoid contact with metal objects that could provide a path to ground. Fifthly, if you are not comfortable working on electrical equipment, hire a qualified electrician. Electrical work can be dangerous and should only be performed by those who are properly trained and experienced. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safety and reliability. Firstly, inspect wiring for damage or deterioration. Look for cracked, frayed, or exposed wires. Secondly, check for loose connections. Loose connections can cause overheating and potentially start a fire. Thirdly, test ground fault circuit interrupters, GFCIs, regularly. GFCIs should be tested monthly to ensure that they are functioning properly. Fourthly, replace damaged or worn out electrical components. Damaged components can pose a safety hazard. Fifthly, have electrical systems inspected by a qualified electrician periodically. A professional inspection can identify potential problems that may not be apparent during a visual inspection. In addition to the technical aspects, it is important to consider the human factors that can contribute to electrical accidents. Firstly, lack of training and knowledge. People who are not properly trained in electrical safety are more likely to make mistakes that can lead to accidents. Secondly, complacency. Overconfidence or a lack of awareness can lead to carelessness and unsafe work practices. Thirdly, distractions. Distractions can cause people to lose focus and make mistakes. Fourthly, fatigue. Fatigue can impair judgment and slow reaction time, increasing the risk of accidents. Fifthly, rushing. Rushing to complete a task can lead to shortcuts and unsafe work practices. By understanding these human factors, it is possible to implement measures to prevent electrical accidents. These measures may include providing adequate training, promoting a culture of safety, minimizing distractions, ensuring adequate rest, and allowing sufficient time to complete tasks safely. When working with electrical systems, always prioritize safety and take the necessary precautions to prevent accidents. Electricity is a powerful force, and it should be treated with respect.